Welcome back, and in this video we're going to be looking in detail at the electrophilic addition mechanism for alkenes. So you're going to need your notes, and we're starting on page 8. So a mechanism shows the individual steps in the reaction. It shows what's actually happening, how bonds are being broken, how bonds are being formed. And we use what we call curly arrows to show the movement of a pair of electrons. Now it's very important that you use these carefully. Students often lose marks because they are sloppy with their use of these curly arrows. Now these curly arrows always start from where the electrons are and they go to where the electrons are going to end up. Now they only ever start from two places. They will start from a bond or from a lone pair. They do not start from anywhere else. So you do need to be very careful to show where your curly arrow is starting from. So let's look in detail at the mechanism for hydrogen bromide and ethene. So we're going to start with our ethene molecule, and we're going to bring up our hydrogen bromide. Now it's important that you orientate this the right way round. In other words, that it's the hydrogen that's pointing towards the carbon-carbon double bond. If it's the other way round, it won't work, because the bromine is going to be delta negative and the hydrogen is delta positive. Now this is an area of high electron density. It's what we call electron rich. The pi bond, the electrons in the pi bond are going to get drawn out. So remember I said you need to start from a bond. That's why we're going to pick the electrons up from this bond here, this one, and we're going to take them to the hydrogen. So you're going to pick the electrons up from this bond and we're going to push them into that vacant orbital on that hydrogen. This is going to cause the electrons in the bond between the hydrogen and the bromine, which are already closer to the bromine than they are the hydrogen, to go fully. And notice again, I'm picking up those electrons from that bond between the hydrogen and the bromine, and they're going to go onto that Br to make that Br negative, to make a bromide ion. I then get an intermediate stage. So I've now added this hydrogen onto the carbon. So there's my extra hydrogen that I've added on. It's now indistinguishable from the other two. I've still got the two hydrogens on here, but because I've done heterolytic bond fission, that carbon has ended up with a positive charge on it. Because both of the electrons have gone onto this bromine has now become a bromide ion. It has a lone pair of electrons. And again, remember there's only two places you can pick up electrons from, the bond or a lone pair. Please don't pick them up from the negative charge, because it's this lone pair of electrons, not the negative charge, which is bonding in to that positively charged carbon. We call this a carbocation. That's a carbon group with a positive charge on it. And we get our final product, which is our bromoethane. So that's the bromo group added on to that carbon. So this type of bond fission, breaking the bonds, remember fission means to break, is heterolytic. Hetero meaning different, lytic meaning to break, because I've broken things up to form different ions. The hydrogen bromide is my electrophile. Technically it's the hydrogen end of the hydrogen bromide which is acting as the electrophile. And the mechanism and the type of reaction we're going through, well, the mechanism is electrophilic and the type is addition. So this is electrophilic addition mechanism. We can also do the electrophilic addition reactions with just halogens, so bromine, chlorine and so on. Again, we get this heterolytic bond fission, so we're going to take our halogen, could be chlorine, could be bromine, and we're going to break it up. So we're going to take the electrons from the bond and we're going to put them purely on to one end. So it's heterolytic because we end up with an X positive and an X negative. So for example, if I took chlorine as an example, both of the electrons would go onto one of the chlorines, so I would end up with Cl positive and Cl negative. And that's an example of heterolytic. And this is going to be my electrophile. In this case, it's got a positive charge. So let's look at the example of ethene with bromine. So if I look at the full equation, I have my ethene molecule, which has the carbon-carbon double bond, and I'm adding bromine, Br2, and I get bromine adding, because this is an addition reaction, across that double bond. The double bond opens up and I get bromine on each of the carbons. So my product name is 1,2-dibromoethane. Notice the bromines go on each of the carbons. I can't get both the bromines on one carbon because I have to add across the double bond. So again, let's look at this mechanism in a little bit more detail. So we're going to start with our ethene molecule, and in the same way I'm going to bring up my bromine. Now bromine doesn't usually have a dipole on it because they're the same atom, so they share the electrons equally. However, as the bromine molecule approaches the electron-rich double bond, I can induce a dipole onto that bromine, because this is an area of high electron density. The electrons in the bond here are going to get repelled from it and are going onto this bottom bromine here. So I'm inducing a dipole, so this becomes delta negative and this end becomes delta positive. So that's my induced dipole. Then the mechanism becomes very similar to the first one you've seen. So the electrons in the bond between the two carbons, that's my pi bond here, come out towards that Br delta positive. The electrons in the bond between the two bromines go from the bond and onto that bottom bromine. And we get the same kind of carbocation intermediate. This case, instead of a hydrogen adding on to the carbon, I have the bromine adding on. Still got the positive carbon there because the electrons in the bond, both of them have gone on to the bromine, leaving the carbon with a positive charge. But as both of the electrons have gone on to this bottom bromine, I've now made a bromide ion. Again, notice I'm drawing in that lone pair of electrons because I'm going to pick the electrons up from the lone pair and I'm going to put them onto that carbon. And again, I get my product 1,2-dibromoethane. My hydrogen's on as well. So again, the type of bond fission that's going on is heterolytic because I'm forming these ions. The electrophile in this case is the bromine, but to work as an electrophile it has to come close enough to the electron-rich double bond so we can induce a dipole, so as an induced dipole on the bromine molecule. And the name of the mechanism is electrophilic. The type of mechanism or the type of reaction is addition. So do need to know the difference between the mechanism, in this case electrophilic, and the type of reaction, which is addition. So that finishes this video just looking at the mechanism of electrophilic addition reactions. And it's a mechanism you're going to need to know in quite a lot of detail. So I suggest you practice it several times, and you'll have the opportunity to do this in class as well. So until next time, keep well, stay safe. Bye-bye.